Hi, this is Mikael from BuildingPoint Scandinavia. Today I'm going to show you how to work with point clouds in Tekla. Today's agenda will be why do we creating a scans, how do we do it, and I'll run a short demo showing you the possibilities that we have in Tekla Structures. Why do we scan? First, we're going to create preliminary designs. We can scan before bidding, so that saves us some time and probably get us ahead of the competition because we can do it faster, do it without any errors. We can start the projects with the detail scan, start design and engineering with clear understanding what's going on. That's you cannot underestimate it. Of course, if you use the scan, you're gonna travel less because one scan is enough. So you don't have to create a lot of measurements. You don't have to go back if you forget something. So one scan probably will be enough. Next one, production and fabrication. That's of course very wide subject, but when you do the scan after welding, you can check if everything is put together correctly. When you create a prefabs, you can check the geometry. You can check that the concrete is laid in the correct way. You can find the errors very easily and without any issues. You can use the scan to check the whole assembly if it's put together in the correct way. And of course, you can use the scan for documentation. During the projects or on site, you can find errors much easier. You can document the process and you can create as builds. What is the scanning workflow in Tekla? Of course, you need to have a point cloud. To do it, usually a geotechnician is going to create a point cloud on site with using scanner together with some kind of software which is connected to that. For Trimble, it's Trimble FieldLink, but for Tekla scanner, for Trimble scanners, it's so simple that you don't even have to use the tablet. You can just use one-click functionality to create the point cloud. As simple as this. When you have a point cloud, it's very easy to send the point cloud to the cloud or directly to the Tekla Structures. What can you do with the point cloud in Tekla? Of course a lot, but to begin with, you're gonna do the visual check, like for the whole thing. If it's correct and not, you can see that some elements are not mounted or placed incorrectly, like yeah, general overview. You can do the dimensional checking, like for the detail check. You can measure distance between the points and the different point clouds, and you can check the deviations. You can use also point cloud as a basis for design. You can just click on those points and create, for example, Tekla objects based on points from point cloud. Here you can see some kind of examples using point cloud in Tekla together with Tekla model. You can see that it's like overlay over Tekla model. I will show you next a demo based on real projects showing use of the point clouds in real world. Of course, you don't need to just do point cloud of the whole structure. You can use also scanning on different elements or different assemblies which are gonna be transferred to the building site before it's sent. It's much easier to correct mistakes in the workshop than correct them on the building site. Of course, you can check the geometry or how the elements are placed on the building site, but not only that. So you can also check what is missing and what is not placed correctly. I will show you in my demo. How you do it in Tekla. I mean the point clouds, of course. You have to first import the point cloud, that's obvious, but if it's not placed correctly, right from the beginning, then you can also align it manually. If it's too big or it's too complicated, so you not see good enough what's in there, you can use, of course, more advanced software to get the point cloud into correct shape or correct size. Maybe not only size, but to incorporate elements only that's in your interest. You have also a freeware tools to do it. I will show you in a second. When point cloud is important and placed correctly, you can do some kind of basis analysis in Tekla. You can check different levels. You can use the class check in Tekla and different stuff. That's going to be in my demo as well. I will try to attach a point cloud. I use global base point here because my point cloud is geo-referenced. This is how my point cloud looks like right after importing. You can see that there are many things there, and this point cloud was basically prepared just to present the necessary parts of the point cloud and the necessary objects. But the point clouds you're gonna pretty often get are much bigger. So for that you can use advanced software like RealWorks to cut it and to fit it, and you can do some kind of adjustments already in Trimble FieldLink. But you have also a very nice tool which you can download from Trimble Warehouse, which is called Point Cloud Manager. You can see that I will just go and turn off the selection here. You can see that the point cloud is just one part of the point cloud. You can see that it incorporates also vegetation and the other stuff like cars and terrain, many different things, which you don't probably need in your model. You can just import point cloud, use the select area functionality, and you can basically just stretch the box to incorporate the necessary parts of the point cloud. Right here, I will just focus on the deck here. Yeah, and it's enough just to click on export, and here I get available three different types of the point cloud that I can export to. And that's how I managed to prepare my export file. So this point cloud looks very tidy. Of course, I can make it smaller just to basically incorporate the small regions of the model. But what I like you to see is that you can fit the point cloud to the work area defined in Tekla Structures. Let us just take a look at this area. Here I can see right away, just like a visual check, that those parts are not in the point cloud. So I can see that those are not mounted at all. So I can create like a report that those things are missing. For the other things, I can basically create a quickly work area that will minimize the point cloud. I'm using work area using 2 points. So I will create a work area like this. The point cloud is still big, but I can just click in this button. I can turn off and on point cloud once more. So you can see that it's cut to my work area. When it's done, you can just click on redraw view or fit work area to entire model, and Tekla will remember how do you cut the point cloud until you turn off and on the point cloud again. This way it's much smaller, much lighter, and easy just to rotate and zoom and pan in Tekla. What I can do with the point cloud in Tekla, I can change the visualization settings, so I can steer the thickness, the strength of the points. I can adjust easy dome lighting, so it's gonna look a little bit like more natural when I have it on. Size and density. Those values are pretty much very necessary, because when you try to compare something, I mean that you're gonna need a little bit more density. Here at the bottom you can see that you can color the point cloud different ways. First one is of course default, so you got the colors and lighting directly from the scan. Next one is pretty interesting, elevation. Here I can do some kind of similar to floor flatness use of this. When I know, for example, at this floor is on the level 2.6, I can use this as a middle value, and I can set the top value at 2.7 and the bottom value at 2.5. So you can see that points are colorized according to those values. So I can see which part of the point cloud is on the correct level, like the green one. Everything below is blue, everything above it's red. That's the one way. I can use also classification, but I don't have too many layers to work with the classification. I think the more interested is the possibility to check the clashes. So I can compare the point cloud against my model. When I turn it on, you can see that nothing has been changed. And it's because if you want to check the clashes, you need to select Tekla parts against which you're gonna check the clashes. So for this test, I will select the floor, and the point cloud is gonna be like colorized according to settings that I have here. So you can see that mostly it's like yellow, so it's below 50 millimeters error. Some parts are red and it's right on, and some other parts which are a little bit off are marked with a different color. But you have to remember that if you want to, for example, check this element against the point cloud, then you need to select it as well. So you need to do it like this. Then you can see how much off will it be comparing to the point cloud. So every time you need to select those objects you need to compare. Okay, let me show you another example of use of the point clouds. Let us just say that we have an element or assembly laying down, prepared for erection, but we need to check first if it's created in the correct way to avoid unnecessary problems a little bit later. What we can do, we can scan this additional object and create a point cloud out of it, and then try to import and place it in Tekla. Of course, this is gonna be not created in a correct coordinate system. It's just gonna be like local coordinate system, and I will just show you how to manually maneuver it in a correct position into your model. So let us just import the point cloud. Remember now to unclick your show inside work area only button, because this is gonna be like limited to this area here. Now click on attach, go to browse and try to import the point cloud. This time it's gonna be model origin coordinates, because this model is not georeferenced as mentioned. So now it's important, but to find it, I need to create an additional view for that. I'll create a basic view, which has nothing with it, and I will turn on point cloud and then right click, zoom to point cloud area. And there it is. I will make a view from the top, but of course it's gonna be fit again to my model, so I need to reuse this zoom to functionality, and then I have it. Of course it's not gonna be rotated correctly, so first we need to check the rotation. So what we're gonna do, we're gonna like place it pretty much very simply to somewhere near our model, or the placement that is intended to be put into. So here, when you click on properties, you can steer the offset or the position of point cloud. But first we need to find how much do we need to offset. So for that I will just use the move command and linear. And then I can check how much do I need to offset it. I use it from here, and with the Control tab I'll go to my main screen, and I will check against this point here. So I know those are coordinates that I need to move my model to. Just need to copy it to X and Y, and just click on modify. And there it is. You can see that it's not properly rotated, and that's because first I need to check the rotation angle. What we're going to do, we're going to measure the angle. So I will check the measure between my model, so objects here, and the point cloud. I will just say that some of those points gonna be correct, and it's 20.94. Yeah, to do some rounding here, I'll say 20.5. What we're going to do, we're going to use the rotation angle here, 20.5. But now I have to delete X and Y coordinates, because we need to rotate it first. So I click on modify, and it's disappeared from here because it's on the native coordinates but with the rotation, and I need to find it once more. Of course I need to click on, yeah. So now it's correctly rotated, but I just need to move it. So once more. from here to here. And now it's going to be correct. Sorry. Then you see that it's placed in a correct coordinate. Right now I can do more work to it. I can check the quality of the prepared assembly. I can again use visualization settings, so I can use the clashes. But then again, of course, I need to select what I'm checking against. So I will check all the objects here. And you can see that it's mostly on zero tolerance, so it's pretty accurate. Of course, I can check the height, but you don't have to actually trust this class check. You can measure everything yourself. So you can use, for example, a clip plane, and then cut through the point cloud. Maybe not here, you can do it right here. You can also use the plan, and you can measure precisely what you need. If you see too much, of course you can use another clip plane. For example, you can create a clip plane on the bottom of this plate. So it's gonna be like very short cut. Again, we are in plane, and now we can see how much off we are. What you cannot do in Tekla, in general, you cannot use the advanced analysis like detailed reports, because Tekla is just to check it with your basic functionalities. So you cannot create a report, you cannot create like floor flatness, you cannot use automatical class check reports, you cannot create like advanced heat maps on elements. You see, I show you that I can use the class check, but it's not the same accuracy that you can get from, for example, RealWorks. You cannot use also Tekla for point cloud registration and combining the scans. It's going to be like separate scans. You have to do it in the FieldLink first, or you can use, of course, RealWorks to combine the scans and georeference them. You cannot do the detailed cleaning in Tekla. I showed that you can do some cleaning and fitting in point cloud engine, but yeah, for detailed cleaning, categorization and stuff like that, you can use RealWorks. And of course, you cannot export point cloud from Tekla Structures. Like I said, Trimble is the very good tool to do most of the job right on the scanning side, because that's what's following with the scanner. So that's going to be your main tool. For advanced point cloud cutting or measurements and reports and stuff like that, I think it's going to be best to use RealWorks. So if you're interested to buy a new scanner, please take a look at new X9 in our portfolio. Thank you guys for your attention.